critical value two-tailed over margin of error all squared. So this is calculation of sample size for proportion. Okay, now I have to read the question and find out what I'm given. Okay, you want to estimate the proportion of adults who have a fear of snakes. What sample size should be obtained if you want the estimate to be within 3% point at 95% confidence interval if you do not have any prior estimate? So we don't have any prior estimate. What does this mean? This actually means that nobody gave you p-hat. Nobody gave you p-hat. So anytime you are not given p-hat, you assume that p-hat is equal to q-hat. So p-hat is equal to q-hat because I don't have any prior estimate. Therefore, I want to calculate sample size in such a way that p-hat is 0.5 and q-hat is 0.5. Okay, so I know the critical value, or I can calculate it because I am told to use 95% confidence interval. So I can calculate the critical value, and that means I will use 5% alpha divided by 2. So parenthesis, the critical value for 0.025, that means inverse norm, multiplied by standard, actually I don't have standard deviation. So divided by margin of error, I am told that it has to be within the 3% point. So it's going to be 3 here, and I'm going to square. So I'm going to square. All right. So now I will use my calculator to answer the question. So I will say now z 0.025. So I will find the critical value second, and then z.025 inverse norm. Number 3.025 is what I have here. The mean is 0, standard deviation is 1. And when I hit enter, multiply, I get an answer. Then I divide that answer by 3. I get an answer. Then I square this answer. Square it. And then I multiply this answer by 0.5 times 0.5 times 0.5. And my answer is 0.1. So actually, my answer is 1 because I have to round up. So the sample size is 1. Some students argue that this is going to be 0.03. So suppose we follow the argument of those students and we put 0.03 there. Let's recalculate here. All right, so if it's going to be within 3 percentage points and where it is, we change that to 0.03, then suppose this is 0.03, that's what I'm talking about. So that argument, I told it, I use it so that if you use 0.03, I still give you the grade. If you use 3, I give you the grade. That way, those who reasoned for 0.03 will not lose. Okay, so I'm doing the recalculation. So inverse norm, the critical value is, everything is still here. So I calculate the critical value for 5%. And I get an answer, divide by 0.03. I get an answer, then I square it. When I square this, I get an answer, then multiply my answer by 0.5 times 0.5, multiply by 0.5, and multiply by 0.5 again. And my answer is 1068. Why 68? Because whether the decimal point is insignificant, you still have to round up. So you must round up. And this answer makes more sense. This answer makes more sense because if you, there's no way of using sample size of 1%. So I kind of take the question, the argument of those who said the percentage point will be 0.03. So 1068. So the sample size the manufacturer should use is 1000. So this, what we are calculating is sample size for proportion. You will be given calculation of sample size. Remember the formula. The formula is in the formula sheet. So I want you to know that this Z alpha over 2 is the critical value for Z. Margin of error means within, whenever they tell you within. Okay, so we have calculated sample size for P. All right, so I think we have done enough examples for today. Let's do one more here. Maybe one more. Let's answer question number. Let's answer question number 8. In this question number 8, we are given the lower bound and upper bound of a confidence interval, and the question only says find the point estimate. That's an easy question. Find the point estimate of the population mean and the margin of error also. So all I need to do is write the lower bound that I'm given and the upper bound that I'm given. The upper bound is 20 and the lower bound is 12. And then if I'm told to find the point estimate, which is the mean of the sample X bar, so X bar is lower bound plus upper bound divided by 2. Lower bound plus upper bound divided by 2, that is 32. 32 divided by 2 is 16. Therefore, the point estimate is 16. Therefore, if I know the point estimate, I actually know the margin of error. The margin of error is 20 minus 16, which is 4. Therefore, margin of error is 4 plus or minus 4. Margin of error is plus or minus 4.